order of reactivity of alkyl halides towards SN2 reaction. Alkyl substitution at alpha or beta carbon atoms in alkyl halide increases steric repulsion to the approach of nucleophile. Hence, rate of SN2 reaction decreases. That is, alkyl substitution at alpha or beta carbon atom in the structure of alkyl halide decreases rate of SN2 reactions. CH3, CH2, 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 say chlorine. The carbon atom bonded to functional group, here chlorine, is called alpha carbon. Carbon atom next to alpha is called beta. This is gamma, this is delta, etc. Consider the molecules methyl chloride, ethyl chloride, isopropyl chloride and tertiary butyl chloride. Carbon atom directly bonded to halogen is called alpha carbon. So these are the alpha carbon atoms. When we move from left to right, alkyl substitution at alpha carbon atom increases. In the first compound, alpha carbon atom is bonded to 3 hydrogen atoms. In the second one hydrogen atom is replaced by an alkyl group, methyl group. The next compound, there are 2 methyl groups or 2 alkyl substituents at alpha position, and in the third compound there are 3 alkyl groups at alpha position. As the number of alkyl groups at alpha position increases, rate of SN2 reaction decreases. Methyl chloride, this molecule have a tetrahedral shape. CH3 chlorine. The nucleophile approaches from the rear side. So here hydrogen atoms are present in the rear side. So approach of nucleophile will be easier. If one of the hydrogen atom is replaced by a bulky CH3 group, the approach of nucleophile from the rear side become difficult. The CH3 group will interfere or interact with the incoming nucleophile. So approach of nucleophile to this carbon atom become difficult or it is sterically hindered. In isopropyl chloride, there are 2 such bulky groups on the rear side of carbon-halogen bond. So due to the presence of these 2 bulky alkyl groups bonded to alpha carbon atom, isopropyl chloride will be less reactive than ethyl chloride towards nucleophilic substitution reactions through SN2 mechanism. In the case of tertiary butyl chloride, steric effect is maximum. Remember that this molecule, the arrangement of carbon and chlorine atom across this central carbon or alpha carbon is tetrahedral. 3 corners of this tetrahedron have a bulky CH3 group and 1 corner have a negatively charged chloride ion. So nucleophile cannot approach a carbon atom of a carbon-chlorine bond from the rear side or from the front side. Front side approach is restricted due to negative repulsion. Here rear side approach is also restricted due to steric repulsion exerted by bulky alkyl group. So alkyl substitution at alpha position decreases the rate of SN2 reaction. This can be generalized as methyl halide is most reactive. Then comes primary alkyl halide, then secondary alkyl halide, tertiary alkyl halide do not follow SN2 mechanism. This is a decreasing order of rate of reaction towards SN2 reaction. Alkyl substitution in methyl halides decreases rate of SN2 reaction. When we compare the rate of SN2 reactions of methyl chloride, ethyl chloride, isopropyl chloride and tertiary butyl chloride, methyl chloride is most reactive towards SN2 reaction. The rear side approach of nucleophile is least sterically hindered in methyl chloride. In the case of ethyl chloride, methyl group attached to carbon atom causes steric hindrance to the approach of nucleophile. In isopropyl chloride, there are two such bulky methyl groups. In the case of tertiary butyl chloride, there are three bulky methyl groups surrounding the carbon atom. The relative rate of SN2 reaction follows 30:1:0.02. Tertiary butyl chloride do not follow SN2 mechanism. That is, methyl chloride is 30 times more reactive than ethyl chloride. Isopropyl chloride is 50 times less reactive than ethyl chloride. So relative rate is in the order 30:1:0.02:0. Rate of SN2 reaction decreases from left to right. Steric effect is also observed at beta position. This is ethyl chloride. Second compound is propyl chloride or a normal propyl chloride. In normal propyl chloride, one of the beta hydrogen atom is replaced by alkyl group. These are all primary. This is primary alkyl halide. This is also primary alkyl halide. Now isobutyl chloride. It is also primary alkyl halide, but it have two alkyl groups at beta position. And last, neopentyl chloride. Alpha, beta. In neopentyl chloride, there are three alkyl groups at beta carbon atom. So, alkyl groups at beta position also exhibit steric hindrance to the approach of nucleophile. Hence, rate of SN2 reaction decreases. The order of reactivity towards SN2 reaction follows. Ethyl chloride is most reactive, followed by normal propyl chloride, then comes isobutyl chloride, and least reactive in this sequence is neopentyl chloride. That is, alkyl substitution at alpha or beta carbon atom decreases rate of SN2 reaction. For a given alkyl group, rate of SN2 reaction follows. Ri is most reactive, followed by RBr, followed by RCl, followed by RF. RF do not undergo nucleophile substitution reaction. It is just included for a comparison. This difference in rate of reactivity is due to decrease in bond enthalpy or bond energy of carbon-halogen bond. Ci bond is the weakest bond, hence it is most reactive towards SN2 reaction. As an example, among methyl halides, methyl iodide is the most reactive, followed by methyl bromide, then methyl chloride. Methyl fluoride do not undergo SN2 reaction under normal reaction conditions. It is included here just for a comparison. This should read as far less reactive. Methyl fluoride is far less reactive than